Okay, here we have a rounded system for developing real-time control applications. We have a model of interleaved buck inverter that is drawn inside Typhoon scheme editor, and it's downloaded onto Typhoon Hill 400 device. First, we start with a model of, here we have interleaved buck converter that is drawn in Typhoon's schematic editor, and after its compilation it's downloaded to the Typhoon Hill. This model, so it has 3 branches that we control through PVM, and we have 2 switches that we use to switch on and off the load. So when we have our inverter running on the Hill 400, then we want to create application program for controlling it. We use Texas Instruments digital signal converter, digital signal processor that is here on the control card, and it is housed on Typhoon's docking station. It communicates through Typhoon through digital input and output, and also analog input and output signals. Application programs are developed in Konchar's graphical environment, and it's a modular structure of the application. So each module is a separate file, so you can move it between applications, and each module that can have 1 or more pages is drawn by adding elements from a programming elements library. Each element is handwritten in assembly, it's thoroughly tested and documented, and and I can show you here. You can see, for example, description of the multiplication in floating point element. The main advantage of our application developing environment is that it is totally deterministic. You define a period of your tasks in a number of processor cycles, and you define order of execution of your elements. So you know exactly when something happens and in which order things are executed. After you created your application program, you download it to the microcontroller through serial connection. We have a graphical interface for loading and for controlling the application. This is its interface. So you can use terminal and you can type commands, for example, to get all the symbols defined in an application, or you can use these graphical buttons to do the same tasks. For example, we can disable PVM signals by simply changing values of some parameters. If we put them to 0 or false, so the PVMs are disabled. We have only 1 branch now working. Or we can put them back to their original value. Also, we have 2 parameters that control states of the switches that turn a load off and on. So let's say we are interested in what happens when the load or to the inverter is switched on. What happens to the voltage at the output condenser? So for that task we have a recorder application. Recorder is a block that is housed in an application, and this is its symbol. So we can add all the symbols and signals that are defined in an application to record their values. Also we can choose which signal will trigger the recorder. So when we set up our recorder, we can also change the position of the post trigger. When we set up the recorder, we send the configuration to the microcontroller. Then we run the recorder. Now it's running. It has no trigger, so it's running in circles. And then we set this parameter that turns on the switch and turns on the load. So the input current will increase, and the recorder will be triggered. And when we retrieve the recording, we have the waveform of the output voltage and the output voltage when it is filtered. That's about it for this short demonstration.